Thank you, Mr. Nakhil. And I would like to welcome everybody with us to attend this introduction about my next course about casing and cementing. As Mr. Nakhil said, this course will be 3 days. It will focus on how to design the casing, the main topic, and how to design cementing program. This will be done as hand calculation, only by hand calculation, not software or Excel sheet. Before I start my presentation, I would like to introduce myself. My name is Jamal Amir. I'm a petroleum engineer. I graduated in 1995 as petroleum engineer from Al-Ba'ath University in Syria. Then I worked for different oil company, international oil companies in Syria and Abu Dhabi. For ADNOC, I worked for ADNOC. Currently, I'm working in Iraq. And I would like to thank Petroleum Engineering Association, BIA, for giving me this opportunity to deliver this course. Okay, shall we start here? I am authorized also as drilling instructor for IWCF level 4. Also, I'm authorized by IWCF also for level 4 well intervention also. Here is my contacts, my mobile, my email. First, as Mr. Nakhil already mentioned the course objectives, and you can see in the website on this side what is the main topics of this course. So we'll go through quickly to cover or review all the topics and which will I cover during the 3 days coming course. Here today, our course will, or this period of time, around 1 hour, it will be to show you what is the topic which I focus on it during our course. For those people who are interested and who like to attend this course, I will share with them before starting our course the material and mainly many examples of casing design by hand calculation and calculator, as we did it before in our college. So I believe that hand calculation, when any person do hand calculations, that means he 100% understands whole process. As you know, now we know, all we know that there are very sophisticated program to design the casing, and it's very easy and doesn't require from us any effort. But sometimes, and I'm very sure that even one engineer or such engineers, they do these casing design depending on the software, and they don't know or they don't understand the actual meaning of this process, or all the process, or the what is the equations he used in this design. So our course will talk today. We'll go quickly about casing purposes, casing types and functions, casing dimensions, casing grades, casing connections, casing depth determination, casing load determination, function of cementing. Also here these topics will focus on the casing. Then we talk about cementing operations, tools which are used in the cementing operation. What is the type of cement operation? Primary cementing, squeeze cementings. How to calculate the required volume of the cement to perform whole cementing system successfully without any fail. Frankly, this 3 hours is not enough 100% to cover this program, because as I told you, it is hand calculation. So for those people who likes to attend this people, we have to prepare what is will present in advance, what we be in advance before we start our courses or as homeworks. So I will give the examples. I will share with you the equations required to calculate to perform all process. So, what is the importance of the casing? What is the importance of the casing strings? In general, we'll talk about the casing strings. Casing strings, generals give us any very important part or in designing of the core of the program. When we design a well, casing design. It's very important part of this one of the whole program, and as cost also it costs 40% of the whole 40% of total cost of the whole construction. So the casing here it will protect our wells. As we know that we are drilling wells. When we drill the well, we will face many different formations. That formation, or sometimes we call it troublesome formation. Maybe we face troublesome formation, depleted formation, high pressure formation, or unconsolidated formation. So if we didn't protect this formation, we cannot continue our drilling to reach to the total depth which is required. So we have to run the casing according to the program. Then we have to cement this casing to make a good bonding between, and also the cementing has to perform the objective of this of the cementing, which is provide good bonding between the casing and the wall, so that we can confirm that our well is fit for purpose. So it will and reliable to operate for the whole duration which is planned or to be on productions. As you know, the well cycle has after a well cycle consists of many stages of. After drilling, we put in production. After production, maybe after few years of working, we have some problems. In analysis, we have some sub problem. So we have to confirm that our cement job is 100% succeed. So it gives us reliable work to work with it. So provide support for weak fractured formations, isolate porous media also for different fluents. Also, as you know, we have freshwater zone when we penetrated during our drilling operation. So we have to protect these formations. So this is brief of main function of the strings. Here we see here as a simplest sketch of the casing of a well. With casing here we have conductor. Conductor it will around 150 to 180 feet. Surface casing up to 2,000 feet. This is vertical well. Some other wells also we have some could be deviated well or directional well or so. So we have here three type of casing. Conductor is as to conductor only to protect the soft soil from washout during our operation. So surface casing here, and intermediate casing and production casing. Sometimes we have, or not sometimes, most of the time we have also here at the end of production we have production liner. Or that the liner casing is not extended to the surface, it's only hanged up here with casing with a liner hanger at the end of the production casing. Well, here this is a description of the casings and function of each of one. We will not go through, just to mention that will focus on our course. Intermediate casing, production casing here. Liner, as I told, is not. It is a kind of casing, but it's not extended to the surface. We do that to save the cost. We have here, as we see here, we have liner. This liner is hanged here at the bottom, at the end of the previous casing. Could be the production casing. We have different type of liner. We'll see them, or we talk about them all in our course. How to classify or the casing. Casing classified according to the size. We have different sizes of the casing. Because we cannot drill a well from surface to the final depths in one size. This is very costly and it cannot be achieved. So we'll drill in the stages, and each stages will be narrower than the previous previous stage. So we have, for this reason, we have different sizes of casing and different diameter of the casing. So classified as size, outside diameter, OD, length, grade. We'll see what is the meaning by grade, weight in feet, how many kg of steel per feet, type of coupling. Also, this casing should be connected together to form a string, or to cover the interval which we are we drilled before. So we will see all type of coupling and the thread also, thread types. As we said, we have different type of diameter. Here we have 4.5 diameter. Each diameter bigger than 4.5 OD is called up to 36. We called it casing, or tubing, or casing, annulars, which is have less than from 4.5 and less. We call it tubing. Length of joints. We have the most common range is 25 to 35 feet. Here we call the range 1, range 2, range 3. Average length 22 feet, 31 feet, 42 feet. What is meant by grade? As we see grade here, we see with this table, we have this table. ABI grade, we have H40, J55, K55, C75. What this number means? What does it mean? And why do we have these varieties of casings? So as we see here, yield strengths, minimum, maximum, tensile strengths, minimum elongation percent. So here, this figure, this number, as we see, it's letter added by number. Casing grade is very much dependent. Letter and number designate each grade. The letter refer, what is the letter refer to? The chemical compositions. As we said, we have different environment in the well. As we said, we have some formation is highly enriched in H2S or CO2. So we call this environment as sour environment, or sour environment. So if we that means that the casing which we use in this area should be different from because it's costly. We cannot use this casing which are designated or specified to used in sour area and sweet area, where we don't have H2S or CO2, because it's costly. If we use this casing, it will the cost of well construction will be increased. So the letter refer to the compositions of the strings of the casing, sorry. While number refer to the what? To the minimum yield strings. Here 80 means 80,000 psi. K55 has minimum yield strings of 55,000. In our presentation we'll discuss each one and where it's best to be utilized. Here H40, we talk about J55, G55 H2 surfaces at all temperatures. So all this we will discuss during our next course. Okay. Here, here we will talk about casing weight. What is the mean is meant by casing weight? Because due to each casing, as we have a different idea. I mean, different the OD it will be for 7. Let's take some 9.58 inches. The OD it's same, but we have different weights for the same. That means the internal ID is different, and the thickness is different for the same OD. That means we have different weight per feet, and each that means the more thick, it's more cost. Here we see ABI recommends here as ABI recommendation for 9.58 casing weight. We see we have different weights bound per feet: 53, 47, 50, 43, 40. Outer diameter it is the same, while inner diameter, as I said, it's different. For that we have different wall thickness and different also drift diameter. We will talk about connector properties. Also connector properties, it will face same loads which casing will face. So tensile efficiency, burst and collapse efficiency, pressure integrity, torque capability, bending resistance. All this connection will face during the life or during the surface when we put it in the surface of the well. So we have different. Here is a connection. We have two type of connection. We have ABI connection and premium connection. What is the difference between ABI connection and premium connection, and where we can use ABI connection and premium connections? Also, the thread we will talk about in our course. We will explain deeply or all these things about connection, premium connection, and API connection. Also, the type of thread. We have different type of threads because as we said, we have different connections. So the different means different threads. We have to be familiar with the threads. Also, as we have API extreme line, API buttress thread. We see all these things. This terminology of threats also we have to be familiar with it here. For the company man who is working on the site, I think he has to recognize when he sees the face or the shape of thread. He has to recognize what is this, what is the type of thread, what is the type of connection. Here we have some failure of threads. Here we have geld thread. We see it. So we put flag here. This is mean damage. Here we have some corrosion here, internal corrosion or bitting we called it. So before use, when we run the casing, we have to inspect each joint threads before run it in the hole. Because as I told, it's very important because this casing is designed to stay to keep in the well for whole time of surface of the well. So this in the future will affect the integrity of the well. Many wells now we facing we call it sub problem. We call this problem as sub problem. What that means, sub problem, that we have problem. It's from its sustained analysis pressure. We have sustained means what that means, sustained analysis pressure. Even if we bleed off this pressure from the analysis A or analysis B or analysis C, that pressure it will return to the previous value which before we bleed off. Analysis A, for that reason, that mean what's the dangers or what's the effect if we have problem on the analysis. I think you heard about the well integrity or something. Well integrity focus that to operate the well for whole period which was designed to work without facing any problem or any release of fluid, oil or gas to atmosphere, to the surface. Because once this fluids or oil and gas released to the surface, we have big impact on the environment, in the company reputation, even if there's some people working there, people. So we have to do this casing job and cementing job successfully without any problem. As I told, if any problem happened, as we see here, if somebody didn't notice any bitting, it could develop a leak in the future. We'll talk about drifting type of threads. We'll talk about is round thread, buttress, modified buttress, square, negative flank, dovetail, other combination. We'll talk about all these things in our course in more details. Here, sealing methods also. Here, forces acting on the tubing or on the casing. We have different force or different load. We have tension, collapse, torsion, compression, burst, bending. All these loads, mainly tension, mainly collapse, burst, and tension. These three loads we have to during our casing design we calculate this value, load value, and we have to apply the design factor as ABI or as, because what does it mean design factor? We will see now in our in next slides, design factor and why we use design factor. We have ABI design factor, or some companies put their design factor according to their experience. So all this we have to calculate them, and Then we select the casing from select the casing that withstand these loads. Also, we have to apply. So it's after if we have what we call biaxial load or triaxial loads, we have all to combine all these calculations together to select the final casing, which will stand, which will withstand these different loads. Not all these. We have also other different uh, effects. Some we have corrosion. We have if corrosion. This corrosion could be enhanced by H2S or CO2. So during our when we have this environment H2S or CO2, we have to select different alloy that will be fit to work in this environment. We have different different failure mode of the casing. This is depending on the threads or premium connection. Here we have premium connection. We'll talk about it. See here how the threads are connected together. Sealing methods. We call it sealing method. Here, principal design of casing. Before when we want to design any casing, some steps we have to take care of about it, or we have to consider it before casing, before we start the casing design. Here, in principle, main things we have to focus about, as we said, casing design include setting depths. What does that mean? Setting depths, casing sizes, grades. These 3 points describe or we mean by it casing design. So when we want to design it, we have to select the setting depths. What does that mean? When setting depths means at which depth we will set the casing surface casing or intermediate casing depth for surface casing about to 1,300 as example feet. But this also this setting depth is another factors affected it, such as if we have high formation brushers, or we have which we expect to have a kick of that formation, or we have depleted formation. So in that formation we maybe will get losses problem. So casing design includes these 3 things: setting depths, we will see it; casing sizes, we will see the casing sizes. Also, we will see the grades of steel that will allow for a safe drilling and completion of a well to be drilled to the desired producing configuration. As I told, the selection of these design parameters is controlled by a number of factors, such as geological conditions, hole problems, number and sizes of production tubing, type of artificial lifts, equipment that that may eventually be placed in the well. Also, another important factor, company policy. Most of the casing design are based. We have to know 2 things, 2 very important things or parameters. We have to know them, which is before we start the design of the casing or the depths. Maximum load, where the casing strength is designed to withstand parting casing, burst, collapse, corrosion, and other problems associated with the drilling condition. Selecting, as I speak already told, that selection of the casing seats required to knowledge of bore pressure. We have to know the bore pressure and fracture gradient of the formation to be integrated. So this is very important parameters for bore pressure and fracture gradient. Because between these two parameters, our drilling will continue, and we have to take care not to have a kick and not to break the formation. So once we determine the bore pressure and fracture gradient, we have to apply margin. We call it for margin for bore pressure and fracture gradient. So we work or we continue our drilling in between these two margins. So here, how we will select? We have two different procedures to select the depths: bottom up procedure and bottom down procedure. Bottom up and bottom down procedure. I will discuss here about bottom up procedure. The second procedure will cover in our course with an example here. Also, I have 3-4 examples. I will share with the people who will attend this course. So as we have here, we have to know our bore pressure before starting our design or our selecting the seating depths or seating depths of the casing, bore pressure and fracture pressure. See here, these two slides here are summarized in this slide. Here we have this graph is showing us fracture gradient, and we have here bore pressure gradient. So we have here bore pressure gradient, and we have here fracture gradient. Here, see, we have another two lines. This one line and this second line. Here between them, we call it drilling window. We have to drill our well between these two lines. We should not exceed them, otherwise maybe you will go to fracture to break the formation, or we will get a kick. So we take this graph by equivalent mud density. So we see, therefore we see here this equivalent mud density is steady, is same value from here, from this point up to this point. That means that the normal pressures, we don't see any pressure, because what as equivalent mud density or gradient, we call it gradient, which is pressure on depth. It is fixed up to this depth around 9,800 feet. Here we see bore pressure changing. That means we have abnormal pressure zone. This is for this bore pressure gradient. As this is other one very important fracture gradient. We have to plot them on our graph or our paper before starting our design. Also, we have to mention also if from the surface up to the final depth. Here we have to mention any problem, any zone or any formation that we have. We call it troublesome zones. We have to mention them at which depth. Okay. And then after that, we have to apply what we call trip margin. What does that mean? What does mean trip margin, and how much the value? Normally we use 0.5 bbg. Why we add this value to hydrostatic pressure we are using to drill the well. This equal about to 200 to 500 psi. For what we add this one? During, as we trip out from the hole, if we trip out fast, it could create an impact called swapping effect. And if we don't have this margin, the bore pressure will become more higher than the hydrostatic pressure, and we will get a kick. For this reason, we add this margin. We call it trip margin. So we have here mud density bore pressure plus trip margin. But in the other side, what do we have? We have kick margin. So we will take, or we will subtract also 0.5 from the fracture. It will come here as a kick margin, we called it. How to select the depth? How to select the depth here? We will start from this point here, from A up to point B. Here, what does that mean? B, it is the intermediate setting depth here. Okay, I will show that by examples here. Okay, so here we take vertical line from A to B to this point, means we determine the intermediate setting depth of casing setting depth. We take a horizontal line from B to C, then again we have take vertical line. It will intersect with fracture gradient minus kick margin at this point. It will form for us the surface setting depth. Here for conductor, we not mentioned here because we know it for 150 up to 180, just to prevent washout of the surface soil, soft soil. Okay, this is an explanation about that one. Here we have other factor. What is the other factor? As we said, okay. Here, theoretically, we call this initial determination or initial selection of the depth. But we have other factor that affect this selection. So if we have here, we select here at this depth around 11,800 feet, but we have here some problem, depleted zone or unconsolidated formation or high pressure zone. So we could manage, we can extend up or less down our setting depth of the formation. So we have here another factors affect, or this factor affect our selections. Here we have example. We will not go through it because I think we don't have time to cover all the things. So we have here vertical depth, we have bore pressure. Then we have to calculate. What we have to calculate here, we have to calculate this factor here, all these things. Bore pressure, we have this data. Vertical depth, bore pressure. Then we have to calculate mud pressure with margin 200 psi. So bore pressure plus 200. So bore pressure hydrostatic pressure will be more than the formation pressure or bore pressure by 200 psi. Bore pressure gradient. What does that mean? Gradient, as we tell, the gradient is a pressure by over depth. So bore pressure. This is the bore pressure. 1320 divided by 3000. It will give us 0.44. Mud pressure gradient. This is for mud pressure. 1520 divided by 3000 will give this number. Mud pressure gradient also here also the same. We divide the value of pressure on the depth. But here how? But regarding fracture pressure, as I told, for this to select the depth of casing, we need very important factor, bore pressure and fracture pressure. This is fracture pressure. Also, we will calculate the we will put margin. So fracture pressure we will calculate it by equation. This is the equation to calculate the formation fracture pressure. We call this formation is called Poisson's ratio, Poisson's equations. Uh, so we use this figure. We have this constant number. So we use this equation, and we have all parameters, so we can calculate this number here, which is fracture gradient. This is, as I told, example here. Same things as explained that will be applied here, and we have here the settings of uh, the setting depth of the casing, as mentioned here. As I told, all these examples will be shared with those people who attend this course before we start our course. So they will work before we start our course. So in our course, we'll quickly we discuss these examples and how to solve them. Here, this is one same with some comment here. What is the meaning of this point? What is the meaning of this point? All this we'll explain in details in our course. Design factors, as I told, we have some design factors. Design factor, we have ABI design factor, and other company, this ABI design factor. As I told, we have to calculate the tension, load, collapse pressure, burst pressure. So we ABI give us this design factor. So if our calculation gives us a certain number for collapse pressure, that result of the collapse pressure we have to multiply by 1.125, so we will get this number. So if we have 10,000 psi, we will multiply by 1.125, we will get 11,000. So this is as a safety factor, just merely as a safety factor. We call this design factor or safety factor to give us higher margin, because maybe we will face problem we didn't consider it during our design program design. So we add this, we use this design factors. So pipe strengths mainly we will focus about burst strengths, collapse resistance, tensile strengths. We have equations. We call it ABI equation, ABI burst for pipe. This is the equation. This equation, if we explain like it, will be, little bit confusing because we have a lot of equation. So just I will go quickly. Because during our, as I told, hand calculation, we will use all these equation. So if you like to start or to do some example by hand calculation, write down all this equation in a separate paper and put it in aside with all cases. As cases, what mean cases? I mean biaxial. If we have axial tension, biaxial tension, or triaxial loads, all this will affect our calculation, initial calculation for this. We will do our initial calculation for burst pressure, collapse pressure, tensile pressure. Tensile pressure, the last one will be calculated, but when we calculate this one and we select it from, we'll select the casing grade or casing from sheet. We will apply biaxial and triaxial load, and this biaxial will affect the result which we get it before. So again, we have to recalculate it depending on the axial load, biaxial load, or triaxial load by using these equations. Biaxial load, this is equation. Also, we have to calculate the burst strengths for coupling by these equations. So we have to calculate burst strengths for the casing. As I told, the casing is connected by coupling. This coupling also we have to consider it during in our design. Then we will calculate collapse pressure. So what does it mean collapse pressure? We have 4 types of collapse regime. Each one you have formula here. All this formula will share with you. Also, a biaxial collapse. What's the effect of biaxial collapse? Here we'll calculate it by this equation. Axial strength. This is the equation of axial strength. By divided by 4. Here the area of casing. Divide and multiply by yield strength. Here area of the metal itself, not the metal of the casing. Metal of the casing. Criteria, as this is just to summarize what we said. There are 3 basic forces which in the casing subjected to collapse, burst, tension. These are actual forces that exist in the well bore. They must first be calculated. Okay, in other words, the collapse pressure must be less than the collapse resistance. Okay. What is the factors or casing design also influenced by what? Loading condition during drilling operation, the strength properties of casing seats, degree or deterioration of pipe will be subjected during the entire life of the well, the availability of the casing. All these factors will affect our selection. Here, maximum burst design. When we internal pressure, here, what does that mean? Maximum burst pressure. When we go for designing, we have to calculate or the most burst load for surface or maximum burst. What does that mean? Burst is the maximum. We will go to the worst scenario which we could face in the well. What does that mean? I will see. We'll see it in next slide. But again, we can say worst scenario is if we have a kick, and that kick and the casing is empty. So at the surface we will face the same pressure at the formation pressure. Maximum burst design. The source of the source of the gas in the highest pressure zone is from open hole formation below the casing. So we have internal pressure and we have external pressure. What is it? Internal pressure and external pressure? We'll go through them in details in our course. We'll explain how we'll get the internal pressure. Internal pressure, the maximum internal burst loading pressure at the surface is a function of injection pressure. What does that mean, injection pressure? Injection pressure mean, as we know, for the well we have depths, total depths, and if we want to calculate the pressure at the formation, so we have maximum internal burst pressure at the surface. Injection pressure here we called it 0.052 multiply mud weight multiplied by the total depth. Here we call the injection pressure. So when we calculate the surface pressure, it is we take the injection pressure minus what? Minus gas hydration. For gas, this we call it gradient for the gas multiplied by surface casing setting depth. So this pressure at the casing, it is the same pressure as the formation pressure minus the hydrostatic pressure in the tubing or in the casing. The pressure in the casing is calculated by depending on the gas hydrostatic gradient multiplied by the depth. External pressure, we call external pressure. As I told, we do all our calculation on the worst scenario. So in our course we'll discuss or explain this in detail, what we mean by external pressure, external pressure at the casing, show internal pressure at the surface. What is the difference between them? Design burst pressure also. The burst pressure is differential pressure between the internal pressure and external pressure. What is the effect of biaxial tension on the our collapse pressure? This will be calculated by these equations. Maximum collapse load design. In these cases, we'll discuss about. In these cases, maximum collapse design will be calculated on these three cases. When we have cement load, when we have green cement pressure, also in the case of evacuated load, how much the column of fluid we'll consider in our calculation. All this we use in our calculation. Maximum collapse design, we have this equation. Effect of biaxial also. Tensile, what is the tensile? This is the third one we calculated it. After we calculate the burst and collapse, and also after considering the biaxial and triaxial load on the burst and collapse, then we calculate tensile design by this equation. It is multiplied by tensile rating multiplied by its area, cross-sectional area. Tensile design factor, then we apply design factor. For all loads, we have to, as I mentioned before, we have to apply design factor. Also, we have to consider also buoyancy effect on the casing. Okay. Here, after we do all this calculation, here we will mention about selection sizes. What is the effect of selection casing size? Here we have this table: casing size, coupling size, common bit sizes used. Okay. Here we have, as I told, examples, casing design examples. I have 3 examples. We cannot, I think, go through. Casing load. This is the 3 loads. For burst, we considered fixed value from surface up to final depths, because this pressure came from the formation. So the formation pressure came and entered the casing up to the surface. Collapse pressure. The collapse pressure is 0 on the surface. Why? As I told, we consider the worst scenario. So we consider that we don't have backup inside the casing, and we have pressure outside the casing. So the casing outside the on the depth, total depth we have here. When the total depth, this is the total depth. So we have here hydrostatic pressure of liquid or cement outside the casing. So we have big value here, while we have 0 value for the collapse pressure at the surface, because we don't have depth here. Zero. The depth is 0. All we considered here our calculation depending on the famous formula 0.052 multiplied by mud weight or cementing weight or cement weight multiplied by total depth. Here tension, the tension also the tension here. The tension at the end at the final depth is 0. At the surface we have the maximum load. So here we have some note before going to examples. We have burst condition, worst condition here, worst scenario we'll calculate. Here we have collapse condition, tension conditions. Then we have this casing number 1 here. Casing number 1, they give us data for one well. For this casing is the 958 inch at 8,000 feet. They give us also mud weight 12.5, formation pressure 6,000 psi, and they told us here we have only one grade available with all weight, only one grade and weights shown in the available in 80 all weights. Also they told us to use API factors, and they told us to design according to the worst possible condition or scenario. So this is before going to any example to solve any example, just we have to make a simple sketch showing the well, the depth of the well, the casing. Also, if we have cementing, also if we have lead cement, how much the height of the lead cement, or how much the height of the tailed cement. All these things we have to write down all information we have. We put it aside here. Design factor we put it aside here. Also steps to solve this problem. So it will be it will be more clear, and the picture it will be more clear to how to and what is the step required to do to solve this problem. So here we applied equation and we get number. We apply equation, we get number. First we as we said, we calculate the burst requirement, the burst, as I told. Here it is bore pressure, as I told. Burst is coming from the bore pressure multiplied by design factor. So 6,000 formation multiply 0.1, it will come this number, this line. So okay, collapse pressure. What is the collapse pressure? As we said, collapse pressure here. The collapse pressure is depending on the formation 0.052 multiply mud weight is 12.5. The total depth multiplied by design factor, it will come 5,850 psi. Here, what is the number here? Okay. we for normal we also here we called it collapse pressure at the casing show. We called it here now. While the collapse pressure at the surface is 0. Here also, so now we have burst pressure. We get two value for burst pressure. We get value for collapse pressure, and we have this table. They give us this table from this we call the API table, showing all grade for N80. We have weight. We have burst. We have collapse pressure. So we have to compare our reading, our results with this table, and we have to select the number which is able to withstand these two values. Okay, like that we do here. We do quickly. Let's take the burst. So we'll come to the burst here, 6,600. So here 6,300, 350. No, we will not take this one. We will take this 6,870. So this one is higher than our results. Okay. So that means we select for burst one. For burst collapse, we select N80 47. We call it N80 47 pound per feet. Okay, and we have this 6,000. But let's come to the collapse pressure. Here we see the collapse pressure is only 4,760, while our collapse pressure is how much? 5,850. So that means this cannot serve or cannot withstand our collapse pressure. So this selection is not recommended. We will go to another selection, which is one here, N80. So we have here burst pressure 7,930, and the collapse pressure 6,620. Here, this is for this example. at the beginning of the example, they told us combination casing string. What does that mean? Combination casing string that we can use for the same string of casing two grade. So N80 we can use means N80 53 and N80 47, but 47 we have to find which dips can with this grade can withstand. See here, I will not go all through this calculation. It's easy calculation, not that complicated. Just to understand the equation, one equation, it's if we understand one equations, it's similar to all equations. It's repeated, only repeated, one stage to be repeated for all stages. So don't be worry about equations. As I told, it's easy. Also, what we see here also, here we call it dimensions, red book Halliburton. I will give you also a copy of that one. Also we can download from internet. It's free download. We can use to select the casing. It's very good and it's easy to use also. See, it will be like that. At the final selection, it will be in this shape. So up to from surface to the depth of 6,369 feet will be in 8047. So this in 8047 can withstand load up to this depth only. How we calculate? It's easy. Not how we find this depth. As I told you, it's by these equations. Okay, it doesn't. It's very easy. Not that too much. While in 80 can be used up to this from this depth to the final depth. This one was 1,631 feet. Here we have another good examples also, but we cannot go through. Here we have also a very good example. Here, surface casing maximum load. We'll do full calculation for casing surface casing. Here all this calculation it will be like that. We will explain all this graph. What does that mean? What all these lines here on the graph? What's the meaning of this one? What is this? The blue one. All this one will be explained in our courses. Again, I repeat that don't be afraid of calculation or equation. When you do this calculation by your hand, you will be more familiar by using soft methods, Excel sheet or another whatever you have software to calculate the casing design. Okay. Regarding the casing, regarding the cementing, now we don't have time only, but we'll go quickly. What we'll explain the cement function. Classes, we call a class of cement. What is a different type of cement and where we can use it, and different temperatures, and also additives. What is the different kind of additives? What's the effect of which one, and why we use this different type of additives. All this calculation will be also main equipment or hardware of casing cementing. We'll explain in details all equipment. That all will be explained. Primary cementing. What is the difference between primary cementing and what second or squeeze cementing, or this will be explained. The procedure in details. what is the meaning of this graph. We'll explain also cement calculation will be explained. We have example also 7 for calculation. Again, as I told, for those people who like to attend this course, all these examples will be handed over to them or shared with them before we start our course. So they will be aware and they understand what we'll do in our course.